Student, let's start with today's topic of class 10th, revisiting irrational numbers. If we just go through revisiting irrational numbers, in class 9th we were introduced to irrational numbers and many other properties. We have studied about their existence and how rational numbers and irrational numbers together are made up of real numbers. Even we have studied how to locate irrational numbers on number line. However, we did not prove that they were irrationals. In this section, we will prove that root 2, root 3, root 5, in general, root p is irrational where p is prime. Now, in order to prove it, we will use contradiction method. Let's start with today's topic and today's question, root 2 be an irrational number. So today's question is prove that root 2 is an irrational number. So in order to prove root 2 is an irrational number, so what we will do, if it is our question, we will assume let root 2 be a rational number. Let us assume that root 2 be a rational number. So we can write root 2 equals to a by b, where a and b are co-prime integers and b not equal to 0. A and b are co-prime integers and b not equal to 0. Now squaring both sides. If we square both sides, what we will get? 2 equal to a square by b square, or we will get b square equal to a square by 2. Now mark it as first equation. B square equal to a square by 2. Here we see that a square is divisible by 2. Therefore we can write a is also divisible by 2, also divisible by 2. A is also divisible by 2. Now after this, let's assume that a equal to 2x. Therefore by first equation we can write b square equal to 2x whole square by 2. So from here we will get b square equal to 4x square by 2, or we will be getting b square by 2 equal to x square. This is second equation. By second, as we have shown in case of 1 that a square is divisible by 2, therefore a is also divisible by 2. So here in this case we can write b square is divisible by 2. Therefore b is divisible by 2. By 1 and 2. Now by first and second, we see both a and b are divisible by 2. Both a and b are divisible by 2. As we find that both a and b are divisible by 2, it is a contradiction. Why it is a contradiction? Why? Because we have assumed that a and b are co-prime integers. That means no other factor is common to b other than no other factor is common to a and b other than 1. So here we find 2 is a common factor to both a and b. Thus it is a contradiction. So our supposition is wrong, and thus you can write root 2 is an irrational number. And this is the proof that we have proved that root 2 to be an irrational number. Now let's start with another example. In another example, we have to prove that, let's prove that one example from exercise 1.3, 6 plus root 2. Let us take an example, 6 plus root 2 be an irrational number. 6 plus root 2 be an irrational number. How to prove that 6 plus root 2 be an irrational number? So we will assume that 6 plus root 2 be a rational number. We assume that let 6 plus root 2 be a rational number. Therefore 6 plus root 2 equal to a by b, where a and b belongs to integers and b not equal to 0. So from here we can write root 2 equal to a by b minus 6. From here we can write root 2 equal to a minus 6b upon b. Here now we find LHS is irrational. LHS is irrational, but RHS is rational. RHS is rational because as a minus 6b and b are integers and b is not equal to 0. Integers and b not equal to 0. So we get left hand side not equal to right hand side, as irrational cannot be equal to a rational number. Therefore our supposition is wrong. What was our supposition? We have supposed that 6 plus root 2 is a rational number. And since our supposition is wrong, therefore 6 plus root 2 is an irrational number. This is the proof of 6 plus root 2 be an irrational number. In this way, in this section, we have seen that how to prove a given number to be an irrational number by contradiction method. So by this video you can solve exercise 1.3. In exercise 1.3 we have 3 questions, question number 1, 2 and 3, and in question number 3 we have 1, 2 and 3 again. So try these questions. If you have any difficulty, leave a comment. I will help you out there. Thank you.